I think we all know this very familiar roots of quadratic equation. For any equation of the form ax square plus bx plus c, we all know that the two roots are given as minus b plus or minus under root b square minus 4ac by 2a. But why is this? How did someone arrive at this formula? And this formula is very helpful, very useful, but we should understand why did this come or how did this come in the first place. Right. This is very easy because this is a quadratic equation and there will be two roots. And let's try to make this is a perfect square. So they see there is a root here. Right. There's a square root here. If there is a square root, let's use this as a hint and try to create a perfect square out of this. How do we create this? Let's see. We all know a plus b whole square is equal to a square plus b square plus 2ab. Right. We all know that. Right. Now let's convert this into a perfect square. How do we convert? First simplify. Let's divide everything by a. X square plus b by a x plus c by a equal to 0. Right. We can transform this into this form. Right. Now let's do one more thing. Let's multiply and divide with 2 of this middle term. X square plus 2 into b by 2a. We are just multiplying by 2 and 2 into x equals minus c by a. Why we are doing this? Because we want to get this into a perfect square like this. A plus b whole square equals a square plus b square plus 2ab. Right. In this case, what we are trying to do? We are trying to make a as x, a as x, and b we want to figure out. What is b? B has become 2 into a into b. B has become b by 2a. B by 2a. So pardon this, instead of the a plus b whole square, we should write it as x plus y whole square. What is x plus y whole square? X square plus y square plus 2xy, or we'll use some other notation because x also we have used. Let's use this notation p plus q whole square equals p square plus q square plus 2pq. Right. In this case, p is equal to x and q is equal to, so this is p square 2 into p into q. What is q? Q is b by 2a. Right. So now what we do? We want to add this q square also. So let's add q square on both sides so that the equation doesn't get spoiled. Right. If we add this x square plus that is p square plus 2 into p into q plus q square is equals minus c by a plus b by 2a square. Right. We are just adding b by 2a whole square on both sides just to make this left hand side as a complete square. Right. Now this becomes p plus q whole square, which is x plus b by 2a whole square, which equals minus c by a plus b square by 4a square, which equals a and 4a square. What is the LCM? LCM is 4a square, and this will get multiplied by a. It becomes b square minus 4ac. X plus b by 2a whole square equals. That means x plus b by 2a becomes square root of all of this, plus or minus, right? X plus b by a will become plus or minus under root b square minus 4a square by 2a. Right, what does that mean? X becomes x equal to minus b by 2a plus underscore b square minus 4ac by under root 4a square, so again 2a, right? So this 2a and this 2a are common, minus b plus or minus b square minus 4ac by 2a, right? The proof is very elegant, but this was not always there. Right, this proof was actually discovered, or this was actually created by this French mathematician, Francois Vitae. Is a great ingenious, genius mathematician. Earlier, people were solving quadratic equations even before this. This he discovered in 16th century. Right. Earlier, also people were using equations like this, but every time they were actually solving or making perfect squares like this. and solving quadratic equations. Now, this gentleman, this mathematician, he has got this idea. Why not put ABC? Why not generalize this? Create a formula. And then he created this formula of minus b plus or minus under root b square minus 4ac by 2a. Right. And he used this clever way of making a perfect square using ABCs. Right. Thank you guys. Hope you understood this. Thank you.